Alright, welcome back to the fourth lesson in Unit 7, and we are going to be looking at the properties of systems of equations. And before we do, we're going to review what we did in the past, solving the system by graphing, okay? So just quickly review, to solve by graphing, what we need to do is to graph both of these two lines and then find out where they intersect. The point of intersection is the solution to the system, okay? So I'll give you a few minutes, give these three questions a try, and then we'll see how that goes. Okay, so you have 3x plus y equals to 9. So the way to graph, I would turn all of them into slope-intercept form. So we have y equal to mx plus b. So we know the y-intercept and then the slope, then we can graph the line. Okay, so this one will turn into y equals negative 3x plus 9. Now the good thing is that you can see the first equations are all the same. Okay, so I only need to do this once. So then I will have that line solved, okay? Or the equation solved, and then I can graph it. Okay, that's negative 3x plus 9. That's, oh shoot. I probably need to move my x-axis down a little bit, hey? 1, 2, 3, 4, 5, 6, 7, 8. Yeah, not enough. Okay, forget about that. Let me move this down a little bit more. 1, 2, 3, 4, 5, 6, 7, 8, 9. Going down 3 and over 1. Down 3 over 1. Down 3 over 1. Okay, so here is my line. Okay, and I'll draw this here as well. Okay, now for the second equation, we have 6x minus 2y equals to 5. Now to solve for y, I would need to move the 6x to the right, so I have negative 6x plus 5. And now divide both sides by negative 2. We have negative 6 divided by negative 2, which is 3x, minus 5 over 2. Okay, 5 divided by negative 2. So the y-intercept is negative 2.5. And I'm going to go 3 up and 1 to the right. 1, 2, 3 up and 1 to the right. 1, 2, 3 up and 1 to the right. So something like this. And to be honest, I have no idea where they intersect, okay? And to be honest, I don't really care, okay? But you can see clearly they intersect at that point, okay? So I don't actually know the solution, but that's not the whole point of this exercise right here, okay? I'm going to do the same thing for these two other graphs. We have y-intercept of 9, which is right here. I'm going to go down 3, 1 right, 1, 2, 3, 1, 2, 3, 1, 2, 3. So here's the line. Okay, now for the equation, we have 6x plus 2y equals to 6. So moving 6x to the right, we got negative 6x plus 6, and then divided by 2, we have negative 3x plus 3. So positive 3, 1, 2, 3 here. The slope is negative 3. So again, I'm going to go down 3 and 1 over, down 3, 1 over, and there is my line. And notice how they are not going to intersect. Okay, there is no solution in this case, right? There is no solution. Okay, in this case, there is a solution. Okay, now what about the last one? Well, the last one, we're going to do the same thing. For the first graph, we have the y-intercept of 9. And we're going to go down 3 and 1 to the right for the slope of negative 3. So there's the first line right here. For the second equation, we have 6x plus 2y equals 18. So first step, moving 6x to the right. And then divide everything by 2. You get negative 3x plus 9. Now hold on a second. Isn't this exactly what we have here as well? Negative 3x plus 9. So I guess I can make this a blue line, and then I can just draw it over it, and we have a second line right here. Now, we said that the point of intersection is the solution. Now, in this case, we have many points of intersection, right? Essentially, every single point is a point of intersection. So what do we say then? Okay, so for the first one, we can see that there's one solution, right? There's one point of intersection. The second one, there isn't any. But this one, there are, or there, well, we have, there are many. Okay, actually, we call this infinitely many because every single point is a solution, and there's just countless of them. Okay, there are infinitely many solutions. Okay, because every single point is a solution. Now, what's special about these, right? How come we have one solution here for part A, no solution here for part B, we have infinitely many solutions in part C? Like, how can we tell from their equations that we have such properties? Well, what you notice, or hopefully you notice this, is that for part A, for the first line, we have a slope of -3. For the second equation, we have a slope of 3. Okay, so they have different slopes. Whereas the second question, you have -3 as one slope. You also have -3 for the second line, right, as the slope. So they have the same slope. So the observation is that this one, different slopes, right? Different slopes. Oops, I spelled slopes wrong. And this one, you have the same slopes. But then you also notice in the third one, they also have the same slopes, right? So what's the difference in part, or compared to part B and part A? I mean, sorry, comparing part B and part C, what's the difference? Well, in part B, they do have the same slope, but the y-intercept are different, right? So same slopes, but different y-intercept. Whereas in part C, you can see not only the slopes are the same, but the y-intercepts are also the same. That's why they are essentially the same line, right? So same slope and same y-intercept. Okay, so this is the moral of the story. If the slopes are different, then we're going to end up with one solution. Okay, if we have the same slope and the y-intercepts are different, then we're going to end up with no solution. And if they have the same slope and the same y-intercept, then there will be infinitely many solutions. Okay, so that kind of makes sense, right? I mean, if they don't go up or down at the same rate, then eventually they're going to meet each other at some point. Whereas part B, they are going up or going down at the same rate, but if their starting point, let's say the y-intercept is different, well, then they will never meet, right? Because they will always go up at the same rate, but then, their starting point is different, and therefore they will never meet. Whereas the part C, everything is the same. Well, if everything is the same, then obviously all the points will be the point of intersection. So that there will be infinitely many solutions. Okay, so that is basically the lesson. Okay, here we go. Here's the summary for that. A linear system with 0, 1, or infinitely many solutions. Okay, so if we have, so here it says, when solving a linear system of two equations in two variables, there are these three possibilities. Okay, we have the intersecting lines, right? We have two lines that intersect each other. That means the point that intersect these two lines, A and B, is the only solution. And this happens when two equations have the different slopes, right? When two equations have different slopes, then we will have one single solution. Or we could have parallel lines, and this happens when, if you write it in the slope-intercept form, they have the same slope but different y-intercepts. Okay. And the last one is what we call the constant lines. That means they are identical. Okay, so they are infinitely many solutions. So what that means is after you simplify them, both equations will be exactly the same. Okay, now the question is, I guess, is then does that mean I need to convert the equation into slope-intercept form every single time? Well, the answer is no. Okay, you don't have to. Okay, but what you need to do is you got to think about, well, if the equation is given in the standard form like this, like how can I find out if they have the same slopes or not? Well, if you think about this, right? How do we find the slope? Okay, let's take this first equation for example. To find the slope, what I need to do is I need to move the 3x to the right and then divide it by the coefficient of y, right? So, and the slope is going to be 3 over 2x minus 3, right? The slope is 3 over 2. So how do we find the slope? Well, the slope really comes from the coefficient of x and the coefficient of y. So as long as the coefficients of the x and y's, they do not have the same ratio, then the slopes will be different, right? So for example, if you look at this one here, they will have the same slope because you can see they actually have the same ratio, right? This is 3 to 2. If you reduce 6 to 4, that's also 3 to 2. And therefore you have the same slope. Okay, you know what? I'll show you this one, and just to show you that they actually will have the same slope if we solve for y. Okay, so from here we're going to move x to the right. So you get negative, oh sorry, not negative 4x, negative 4y equals negative 6x plus 8 divided by negative 4. Negative 6 over negative 4 is positive 3 over 2x. 8 divided by negative 4 is negative 2. You can see that the slopes are the same. Now, okay, so if the slopes are the same, then y-intercept matters, right? Well, clearly in this case, these two y-intercepts are different, and therefore they would be parallel lines and therefore no solution. So then the other question then is, then how do I know if they are, they have the same y-intercept or not? So apart from, having the same ratio for the coefficients of x and y, we'll also look at the constant. So notice how that if you multiply 3 by 2, you get 6. Negative 2 times 2 is also negative 4. Again, that's why they have the same slope. But if you multiply 6 with 2, that gives you 12, and here this gives you 16. They do not give you the same value. And actually, sorry, you don't need to multiply the 8 by 2. Okay, if you multiply 6 by 2, you get 12, and notice how 12 and 8, they are not the same value, and therefore the y-intercept will be different. Okay, and as you can see here, that's negative 3, and that's negative 2. So in part A, there's no solution. Again, because same slope, different y-intercepts. Okay, now let's look at part B. Well, what I do notice is that the coefficients of x and y, they do not have the same ratio, right? That's negative 2 to positive 4. This is 8 to negative 8. So this is negative 1 to 2 ratio. This is 1 to negative 1 ratio. Again, the ratio is not the same, and therefore they will not have the same slope. So if they don't have the same slope, we already know these would be two intersecting lines, and therefore there is going to be one solution. Okay, one solution only because different slope. Okay, because of different slopes. Okay, finally in part C, now in part A and part B, they were both written in standard form, so we can compare like that. In part C, they are written in different forms. Okay, so then we should, in this case, probably convert everything into slope-intercept form. Now, luckily, the first one is already done for us. We can try the second one here. We can then, I'm gonna actually move 2y to the right instead. So I don't need to, instead of moving 2 terms, I'm moving 1 term only. And now divide both sides by 2, you get 3x minus 4 equals to y, which is exactly the same as that. And therefore, these two lines are identical, right? They're coincident lines, and the equations are identical, as you can see. That means there are infinitely many solutions. Infinitely many solutions. Okay, so again, to figure out how many solutions we have in the system, all you have to check is whether they have the same slopes or not. If they have different slopes, that means one solution. If they have the same slope, that means you need to check their y-intercept. Okay, see if they're the same. If they are not the same, that means they are parallel lines, and therefore no solution. If the slopes are also the same, then that means these two lines are identical, and therefore you have infinitely many solutions. Okay, so here we go. Here's the next example. It says, given the equation negative 6x plus y equal to 3, write another linear equation that will form a linear system with, okay, part A says exactly one solution. So again, exactly one solution means different slopes, right? Well, if we want to have different slopes, that means the ratio between the coefficient of the x and the coefficient of y must be different. Okay, well here the ratio is negative 6 to 1. So let me just make a random equation that has, a ratio that's not negative 6 to 1. Let's say negative 6 to 2. Okay, now you can see the ratio is different already. So for the constant, it doesn't really matter. Okay, you can make them the same or make them different. Okay, that does not matter because the ratio is already different. And therefore, again, this creates the different slope. Okay, for the case of no solution, this means we have to have the same slope and different y-intercept. Okay. Well, if we want to have the same slope, that means the ratio of the coefficients of x and y must be the same. So we want to make it negative 6x plus y as well. But the y-intercept must be different. Therefore, you need to change the constant term. Okay, so instead of 3, you can put, well, really anything other than 3. Okay, and then that'll be good because you have the same slope, again, because of the same ratio between the coefficients of x and y. The y-intercept will be different because the constant is different. Okay, so for the infinitely many solutions, that means same slope and same y-intercept. Okay, that means you can simply multiply everything by 2, right? So then, if you reduce it, you'll be exactly the same equation. Okay, obviously you don't have to multiply by 2. You can multiply by negative 1, negative 2. You can multiply by any constant. Okay, as long as you multiply to every single term. Okay, so that's the properties of linear systems, right? You can tell how many solutions we're gonna get depending on the slopes and the y-intercept. And different slopes means exactly one solution. Same slope but different y-intercept would be would be no solutions at all because it would be 2 parallel lines. If they have the same slope and same y-intercept, that means they're identical lines. Therefore, you have infinitely many solutions. Okay, so that is it for this lesson. Do some questions, and if you have some questions for me, let me know. Okay, good luck.